Welcome back, students. Till the last video, we discussed problems around trigonometric identities. This and in a couple of videos, we'll discuss more of board problems across trigonometry. So presently, we are covering all of this, not one specific, and we are covering board problems across all of these topics. If you have not viewed these earlier videos, please check video number 9, 10, and 11 for better understanding of solving these problems. Also, I am using this question bank to pull out these problems and show it to you. I'll also even solve the recently shared 2026 sample problems. See, I'm not trying to solve every problem. I'm trying to pick up one sample or a repeated pattern so that I can cover different models. Now you have to pick up the other problems, practice it yourself, and make your learnings perfect. The more the problems you practice, the more patterns you see, and you can familiarize with the patterns when it comes in front of you. So even as I teach, please pause the video and try solving those problems. So going to the problem. Now here you have the value of sine square plus 1 by 1 plus tan square a. They are asking the value for this equation. There are two methods to solve this. I'm going to show both of you. So in the first method, what I'm going to do is just I know the value of tan square. So I'm going to tan is sine by cos. I'm going to substitute that. So sine square plus 1 by 1 plus sine square by cos square. I'm going to take the addition. I'm going to add both these terms. So cos square comes here and cos square goes in the denominator. So sine square plus cos square, the denominator goes to the numerator here, this part. So this addition, this whole equation after addition becomes this way. And now you know sine square plus cos square is equal to 1. So this becomes 1. And again after putting this 1, you are left with one more sine square plus cos square, which is also equal to 1. So you have an answer of value of 1. There's another method which is more easy. My preference is always a simpler method which you can reach the solution. According to trigonometric identity 2, 1 plus tan square is equal to 6 square. So I'm going to substitute this 1 plus tan square a is equal to 6 square a. That leaves you by 1 by 6 square a, which is nothing but inverse of cos square a. So I make the inverse. I'm going to replace 1 by 6 square a with cos square a. Then finally we are left out with sine square plus cos square a is equal to 1. So both give the same answer. So problem number 2. 1 plus ck by ck is equal to sine square a divided by 1 minus cos a. You have to prove that this both are equal. So what I do is I start from the left hand side. This is a slightly different approach where I have taken. I solve both left hand side and right hand side to some extent where you get an equation. That equation is going to be same, and thus you are going to say that left hand and right hand is equal. So let us see 1 plus 6 square a by ck is equal to, I am going to substitute cos in place of both of this. 1 by ck is nothing but cos a, I am putting here. Then ck is 1 by cos a, I am going to add here and going to add it. After adding, we are going to get 1 plus, we are going to get cos a plus 1 divided by cos a into cos a. So cos a gets cancelled and you are left with 1 plus cos a. Similarly on the right hand side, this is similar to trigonometric identity 1. So sine square is equal to 1 minus cos square a divided by 1 by cos a. This 1 minus cos square a can be divided as 1 plus cos a into 1 minus cos a based on the algebraic identity a square minus b square. This you treat as a square, this you treat as b square, which is equal to a plus b into a minus b. So that's what I am put here. 1 minus cos a, 1 minus cos a goes away. You are left with 1 plus cos a. Now you can see solving LHS and RHS gives you the same value of 1 plus cos a. So you are proving that both are equal or both are same. Now problem 3. So by seeing this, what you can feel is there is a pattern like cosec and cot come in the trigonometric identity 3. So have that in mind. So let us see how to solve it. Here I am starting with left hand side. 1 plus trigonometric identity 3 I am going to substitute here cosec square a minus a divided by 1 plus cosec a. And this I'm again going to decompose our a square minus b square formula. A square minus b square. Okay, this is 1 plus cosec a into 1 cosec a plus 1 into cosec a minus 1. In the denominator you have one more cosec a, so this and this gets cancelled and you are left with cosec a minus 1. This minus and plus 1 gets cancelled and you are left with cosec a, which is nothing but the right hand side. So thus you have proved left hand side is equal to right hand side. Then this is problem 4. Looking at the presence of tan and sec, you should have a trigger that this is related to trigonometric identity 2. But you have one problem, like the equation what you know deals with tan square. Here you have something called as tan power 4. So you can convert tan power 4 to tan square by making tan square to the power of 2. So let us see the approach. Let me take the left hand side. Tan power 4a plus tan square a is equal to, I am going to take out tan square a common outside and open the bracket. Thus tan power 4 becomes tan square a plus 1. This is equal to tan square into, you are going to apply the trigonometric identity 2, that is 1 plus uh, tan square a is equal to sec square a. So you get the product of tan square a into secant square a. Now I am going to do the same to the other side of the equation, right hand side. Secant square I am going to pull outside and within the bracket I am putting secant square minus 1. So here again I am going to apply the trigonometric identity. Secant square I am going to keep it as it is. Secant square minus 1 is equal to tan square a. So you can see left hand side and right hand side both are same. So you are proving it. There is also an alternate way which we will see how to do it. The tan power 4, the first step left hand side, I am taking the left hand side. Up to this is same as the previous step. Then what I'm going to do is I'm going to apply trigonometric identity 2 for both these places where there is tan square. This tan square a becomes secant square minus 1. Okay, this tan square becomes secant square minus 1. Then here also I'm going to substitute tan square plus a is there, right? There also I'm going to substitute secant square minus 1. Or 1 plus tan square a is also is secant square a, whichever way. Then you are left with secant square outside. You multiply the secant square a with each of these terms, pulling inside the bracket. Okay, and you get secant square power 4 minus secant square a, which is your right hand side. So that's, you have proved it. Problem 5. Sin a plus cos a is equal to root 2 and you have to prove tan plus cot is equal to 2. See, sin plus cos as such you cannot do anything, but if you square it you can bring somewhat the identity of trigonometric identity 1. So that's what we are going to do it now. Left hand side I am going to square both sides by applying a plus b whole square formula. Sin square a plus sin square a plus cos square a plus 2 into sin a into cos a. Now you know sin square a plus cos square a is equal to 1. So it becomes 1 plus 2 sin a into cos a is equal to 2. This 1 I am going to take it the other side. So 2 sin a into cos a is equal to 1. This is what you get for the left hand side. Now we are going to solve a bit on your right hand side also to see whether you are getting the same equation. So right hand side is equal to, I am going to substitute their base values. Tan a with sin a by cos a and cot a with cos a by sin a. Tan a is equal to sin a by cos a. Cot a is equal to cos a by sin a is equal to 2. So I am going to take the LCM and add it. Cos a sin a. On the numerator it is going to become sin square a plus cos square a, which is equal to 1. Therefore sin a into cos a is equal to therefore 2 sin a into cos a. This cross multiply, this 2 is going to be multiplied with the numerator sin a cos a. Therefore you get 2 sin a into cos a is equal to 1, which is your same as your left hand and right hand side. So thus you have proved it. So in the coming video we'll see another 4 or 5 more problems. Thank you and bye till then.